Can we start it? Okay. Can you sit? We'd like to start the next session. Next session is technical session 1. Thank you for participant this program. My name is Shishio Tsuchiya, APNIC 46 program committee member. I'm basically providing a solution. I'm working at Arista Networks Japan. I'm basically propose my solution and product to the customer, and I also contribute external community. So this time I will do as a moderator of this session. We have three programs and 4 presenters on this session. The first program is Ira. She will explain the approach to the network automation. Network automation is a very hot topic within the network operator, but approach of the network automation is depend on the size of the network topology and depend on the number of equipment. Then let's start presentation. Please welcome Ira.
Thank you. Good afternoon. My name is Ila. I'm based out of Singapore. I'm an engineer with Arista Networks. And I primarily look at software and automation platforms and helping customers as to how they can achieve certain use cases or goals by using programmable and programmability solutions. So a bit about Arista Networks. We're the leaders in cloud-grade data center switches and routers. We've had a phenomenal last 9 to 10 years with really, really good growth. We've up to now 15%, more than 15% market share, and 15 million plus ports shipped. We've been recognized by Gartner and the Forrester Wave as part of the leader quadrant in data center switching, routing, and software-defined data centers as well. I think the crux of the reason behind all of this positioning as in the leader quadrant is mostly because of our hardware strategy by using merchant silicon, as well as our software strategy where we have a single operating system across all our hardware platforms. The reason behind having a single operating system is very simple. Because of the uniformity and the modularity that the operating system allows us, it gives us a unified approach towards programmability and towards automation by leveraging on the modular aspect of the operating system itself. So the case for network automation then, that becomes the foundation for it. When you're able to have a programmable software platform to build on, network automation becomes that much simpler. But network automation, the case for it is quite, the chart speaks for it all. If you see the growth of internet traffic or IP traffic up to 2021, which is not very far away, out of the 278 exabytes globally, more than 108 will be out of Asia Pacific itself, with a regional growth of around 26%. And those are quite mind-boggling numbers if you think of how, as organizations have to scale our infrastructure, our expertise, and our people in a way that we'll be able to handle all of that traffic gracefully. Of course, as you heard in the morning's keynote presentation, the drivers are IoT, mobile adoption. 70% of all IP traffic will be just VOD or video on demand traffic. And so in order to handle all of that, I think we have to scale ourselves, both in terms of skill set as network engineers, but also in terms of the size of the teams that are able to deal with this. But of course, that's not very That's not very reasonable, is it, to kind of scale your team as much as the traffic grows? Also because 80% of today's operating expense is spent on keeping the lights on. So when we think of the future of how this is going to go, NetOps in 2021 it seems to be quite a task, right, with the current approaches that we have, which may be more manual, which may be more box by box, with a lot of network engineers having to do a lot of custom manual work by hand every day. So when we think of network operations, we're also thinking of how the data center is evolving in order to deal with the kind of IP traffic that we are seeing. We want to move away from vertically integrated proprietary stacks, and we want to move towards a more open architecture where you have applications that are not dependent, infrastructure that is not dependent on applications. Also, we want to have best-of-breed ecosystems where we take advantage of the different components of the industry that give us the best performance, not just being locked in by vendors. And of course, we want simple and repeatable and scalable architectures, right? Irrespective of what exact network design that you may adopt, we want the software-defined data center to be programmable, open, modular, and easy to deal with. So in our experience, what we've seen when we work with customers on a day-to-day basis and their approaches and what we recommend to them for network automation, we can kind of divide into three broad categories, right? The first one is, of course, DIY. Typically, these are smaller enterprises with maybe a larger software development team or a software programming team. And because of the scale not being too large, there is the scope of being able to write custom applications or custom platforms in order to maintain and manage the infrastructure. In order to deal with this sort of environment, we typically tend to suggest that the teams use SDKs, that is the software development kits, or APIs in order to write these custom applications and to drive those use cases for their infrastructure. The second use case is for slightly larger environments where you probably have more than 100 network elements that you want to work with. This would be typically using open source tools like Puppet, Chef, which are existing in the market and which allow you to do things like configuration management that have been used by other industries before. Like, for example, software developers probably use these kind of tools for other applications, but we're now trying to use them internally into the network environment. So for this particular use case, we would be suggesting to maybe use the DevOps integrations that we have, which would probably give you a slightly more, less granular approach than the DIY, where you write your scripts and you write your deployments yourself, but more to leveraging the open source tools from a DevOps perspective. The third customer spectrum is when customers they don't really probably have teams that can do the scripting and can manage the DevOps deployments that they have. They just want a tool that works. So in order to deal with a network scale that may be up to 1,000 devices or so, the approach that we take is usually to suggest using a software platform that does provisioning, that does telemetry, that also allows you to do things like software-defined networking, orchestration, and so on. So essentially, these are the three approaches for the network automation that we have seen. But of course, this is not strict. For example, like I've seen large deployments where we use the software platform, but we want to enable custom use cases which can only be done via leveraging the SDK or the API. So it's a very flexible intermingling of all the three options, and it really depends on the use case at hand. So just a deep dive into each of the three approaches and what they really mean. The software development kit approach, which is the DIY approach, is essentially writing native